for those who aren't here. So we're carrying on with one of my favorite topics of vectors. Just before we start, just to repeat what I said yesterday, I think as we start getting onto things that are that little bit trickier, it's absolutely fine if you don't get 100%. I don't want you to feel you've got to keep going back and going over and over and over and going over your time allocation. Obviously, if it's just taken you 5 minutes to do 75% or 50%, then I do expect you to go back and improve your mark. But if you're coming towards the end of the allotted time, it's absolutely fine if you settle for whatever mark you've got. But as you upload your notes, please can you just say, yep, I've got a full understanding. I just made a couple of silly mistakes, or basically I need you to confirm that you understand where you went wrong. Okay, because it's not like I can look over your shoulder at the moment. So when you get a mark, 100%, you don't need to worry. Clearly you've got a full understanding. Anything less than 100, I want you to just make a comment on the page that you understand where you went wrong. So I don't want you just emailing me and telling me that, because then I want it in your notes. Okay, so when you go and upload the work, I want you just to go and write it on there. Now what we're moving on to today is parallel vectors. Now, as you know, vectors have got two properties. They've got direction and they've got length. Okay, now if they've got the same direction, then they are parallel. Okay, it doesn't matter about the length. Okay, so what we're saying, these three vectors are parallel and they are all multiples of A. That one there is 2 lots of A, that's a half an A. But the way you go and show that a vector is parallel, you've got to work out what both of the vectors are and then just conclude and say, yeah, one's a multiple of the other, therefore they are parallel. Or if they're not, say this vector was A and another vector was A plus B, well, clearly they're not parallel because they're not multiples of the same vector. So that is our goal. Now, 632 is what you're going to be doing, and it's got 4 questions. I've gone and modelled an example of questions 1 and 2, and then secondly, I've gone and modelled an example of questions 3 and 4. So this was a modelling of, oh no, actually, I think I lie. I think I decided 1 and 2 were quite straightforward, and I've just modelled 3 and 4, I think, the harder 2. So here's question 3. So let's just take our time on this. Vertices, remember that means corners. O, A, C, and D form a trapezium made from 3 equilateral triangles. And M is the midpoint of CD. So let's just process all of that information. So M is the midpoint of C and D. So just go and pop in that they are 1 mile each, if you like. Now, because they are equilateral triangles, given that that is A, that is also A. It's the same length and the same direction. And given that that from O to B is 2B, then B to D is 2B as well. Ignore those green bits for now. Okay. Now, we're being asked to express the vector OC in terms of little a and little b, and the vector BM in terms of little a and little b, and then to comment on whether they are parallel or not. So let's just have a look. So vector OC, that's really what I've done in green. That's what that looks like. And vector B to M, that's what that looks like. And we've got to go and say, are they parallel or not? So in turn, we're going to work out the 2 vectors. So in a way, this is just similar to what we've done before. So let's kick off by working out vector O to C. Now, how can I go from O to C? I'm going to choose to go from O to B and B to C. O to B and B to C. And then am I able to go and move over to the alternative format of just little a's and little b's? Yes, I can, because O to B is a 2B and B to C is a little a. And just as a nicety, I'm just rewriting that in alphabetical order. So A plus 2B. Now, just going to come back to this business. I've noticed when you've been uploading your workings, some of you are still in the habit of giving me a line of workings where you're mixing a combination of little a's and little b's with the capital letters with the arrowheads. You mustn't do that. It's got to be all or nothing. So make sure each line of working is either in this uppercase arrow format or alternatively in this lowercase a and b format. Don't mix and match. So vector OC is a plus 2b. Let's start again. Let's go from b to m. Now, how can I get from b to m? I could go two different ways, but I'm going to choose to go b to d and then d to m. So I'm just setting the scene which way I'm going. I could have gone that way, couldn't I? I could have gone b to c and c to m, but that's my choice. Now, I've then made the point that dm is half of dc because m was the midpoint. So dm is the same as half of dc. And then in your head, you're thinking, am I in a position to go over to the alternative format? Yes, I am, because b to d is 2b, and d to c is this, boom, boom. So it's minus 2b plus a. So capital letter arrowed format to lowercase a and b format. You then process the algebra. You do your claw. Half of minus 2b is minus b. Half of a is half of a. Gather your a's, gather your b's, and pop it, again, as a nicety, but just put it into alphabetical order. Now, I can see that a plus 2b is double half of a plus b. So for the purposes of this comment that you get in the comment box, giving a reason, explain if it is parallel. Yes, it is parallel, and you can either say that BM is half of OC. Obviously, that is half of that. Or alternatively, of course, you could just say it the other way around. You could say that 2 lots of BM equals OC. But you're basically just explaining there, it doesn't matter which one you choose, that one is twice the other, okay? And because it's a multiple of the same vector, they are parallel. So because they're multiples of the same vector, you can conclude that OC and BM are parallel. So that's question 3. So similar idea. Let's just process question 4. P and Q are the midpoints of OB excuse me, and AB respectively. Okay, so it wasn't, I think it was too clear here. This diagram, that is 2P all the way down from O to B. Okay, and so that's a midpoint, so let's call that 1 mile and that 1 mile, and Q's a midpoint, let's call that 1 mile and that 1 mile. So, and obviously we're told that OA is 8A and OB is 2B, 8A, 2B. So let's go and see what they're asking us to do. We've been asked to work out the vector PQ and the vector OA and conclude whether they are multiples of the same vector. Now, straight away, we can obviously see that OA is 8A. So when we do our workings for PQ, as long as we finish up the multiple of A, it is parallel. If we had some B's in there, then it isn't parallel. So let's go and work out what P to Q is. 2 ways you could go. Okay, you could go this way, P to O to A, and then A to Q. I'm going to go the shorter way. I'm going to go to get from P to Q. I'm going to go P to B and B to Q. Boom, boom. So what is BQ? Well, BQ is half of BA. Put that Q as a midpoint. Now, can I move over to my alternative format? I can nearly, but I'm just going to go and rewrite BA in its, how do I get from B to A? I go B to O and O to A. So I've just put in this extra line of workings. And can I go to alternative little a, little b format? Yes, I can, because P to B, now P to B is half of 2B. So that's obviously just a single B. Okay, we've got a B there and a B there, giving us our 2B. So P to B is B, and then I'm doing half of B to O plus O to A. So B to O is obviously going down the 2B the wrong way, so that's a minus 2B, and obviously O to A is my 8A. So process the algebra with your double claw. Half of minus 2B is minus B. half of 8a is 4a, and then it's really nice. This is what you were hoping would happen. The b's cancel out. B take away b is nothing, so you just got 4a. So clearly PQ is parallel to OA. It's half as long, but it's still parallel because they are both multiples of the vector A. Okay, so how would you conclude this? You'd say either that 2PQ, two lots of PQ equals OA, or you'd say half of OA equals PQ. But because they're multiples of the same vector, you can conclude that they are parallel. So that's it, folks. So please go and have a go at Hegarty 632. Do, as I said, if you get 100%, that's great, and I love it when I see your workings. If you don't get 100%, it's really important that you let me know that you understand where you went wrong. Okay, so ideally you do that by uploading your workings and writing a comment on it. Some of you still aren't uploading your workings, but if you haven't got 100%, the very least you're going to have to do is just go on to the page that you should be uploading to and writing a comment in a text box that, yep, I got 75%, I know, but I confirm that I understand where I went wrong. Okay. Okay, guys, that's it. Nice that so many of you joined me. I hope you get on well with that. Obviously, as always, I'll be here keeping an eye on Teams for any queries you may have, and I will be transferring your marks across from Hegarty onto Teams. Bye.